is retroperitoneal, meaning it is behind the body wall lining. And so it needs a connective tissue covering in order to anchor it in place. Okay. If we have a kidney, we have a ureter that would lead to a bladder in this area. And a bladder would then lead to a urethra. The urethra would then lead to the outside world. I'm going to the next. Kidney ureter bladder model, anterior view. So we see the kidneys. We see the ureters. We see the bladder. Okay. And this is a male bladder. Okay, I'm going to move it up a little bit. This is a male bladder because there's a prostate gland.
Nice face.
Okay, everybody with me?
Yeah, that's good.
Thank you. Okay. In the kidney, just like in the stomach, are rugae. Okay, that's because the bladder, I should have said bladder, in the bladder are rugae because the bladder is capable of expanding and contracting, just like the stomach was capable of churning. There is smooth muscle called distruster muscle, and there is a umbilical ligament, okay, that was anchored to the kidney and then went to the liver. There's a smooth area called a trigone.
For real?
And there is an internal and an external urethral sphincter. We don't see the external on this. External is skeletal muscle, internal is smooth. The urethra goes through three things, so it will have three different names. This is only showing one. When it's in the prostate gland, it is the prostatic urethra.
Are you using this?
Okay, everybody got that?
Yeah.
Thank you. Okay. This is showing you where it's located in the body cavity. And again, this would not be uncovered like this. This would have the peritoneum over it. Going on to where it's located, okay? So the pancreas is also retroperitoneal, and the adrenal glands are also retroperitoneal. So this is just giving you the relative position in the body. Okay. Now we're looking at the same model from the posterior. So if we're looking at the posterior, now it's left and right is on the right sides. If we're looking at it from the anterior, it's reversed. This is one of the models called the green board, and it contains a great deal of information. Okay. First off, we have a kidney, an entire kidney. Then we have a portion of the kidney over here. The portion would look like this and then go up into the area that is above that. So this is cortex. We have an artery and a vein that separates the cortex from the medulla, and these are called the arcuate arteries and veins because they're arcs. They're semicircles. So that is the delineation between the cortex and the medulla. Here we see a much enlarged single renal lobe. Okay? Cortex, and then below the arcuate artery and vein, medulla. These white circles are Bowman's capsules. So here is an enlarged Bowman's capsule. Okay. Now, they're calling it the renal corpuscle because if you take Bowman's capsule plus the little tuft of capillaries, that's glomerulus, if you take them together, that's the renal corpuscle. So if I ask what's the white, that's Bowman's capsule. If I ask you what's the red and white, that's glomerulus. And we're going to discuss why it's red and white. If I ask what's the white plus the capillary network, that's renal corpuscle. Everybody understand that?
Yeah.
Okay.
Could you just go over that a little, Professor?
So the nephron starts out with Bowman's capsule. And the function of the kidney is to filter your blood. And the way it does that is by a capillary network that is perforated, which we're going to see on another picture enlarged. And then there is cells covering, they're showing uncovered and covered, cells covering this capillary network. This capillary network is called the glomerulus. So a renal corpuscle is Bowman's capsule plus glomerulus.
Dude, they filled up like
Got it?
those like things.
That's insane.
I was like, yo, what the fuck? They say you had a pipe.
Got it.
Okay.
I know that.
So moving on.
I know, so I'm kind of scared right now.
Okay. Now this is back to a single portion of the big kidney, and we have some definitive areas. Here's the cortex above the arcuate artery and vein, and these pyramid shape, or we're only seeing it in sections, so it is a triangle. But if we go back up, and I'm just going to go right back up
I think.
Yeah.
Did you hit the button?
to this picture, you can see they're rounded. So they're rounded like a pyramid. Hi guys, you're late, so we're already well into this.
Is it?
Sorry, I was kicked out. I don't know why.
Yeah.
Okay.
Okay. So we're down to this kidney nephron glomerulus kidney model frontal
Yeah,
section.
you good.
And we have a cortex and a medulla. Now, the medulla is below these arteries and veins. They are called the arcuate artery and vein because they make an arc. Above it is cortex, below it is medulla. Now, medulla consists of these pyramids where we find all the nephrons. But we also find portions of the nephrons in the cortex. And this is an amazing design. We'll get into a little bit of the physiology in a bit. So the renal pyramid is where we find this portion of the nephron, and we're going to look at it in a large portion. And it is the renal cortex where the kidney allows the body to reabsorb some things that got filtered out of the blood. We'll talk more about that when we get to an enlarged renal corpuscle. So anyway, in here, we're going to find a lot of the water. And we're going to find it in tubules that lead to these areas that are called the renal the renal a minor calyx. When we join a couple of minor calyxes, we get a major calyx. When we join all of the major calyxes, we get a hilum. And in the hilum, we're going to find the renal pelvis. The renal pelvis is going to lead to the ureter. Everybody got that?
Yes.
Okay.
So when you have the minor calyx, house that goes into the major calyx.
So the lung had a hilum also, and the lung's hilum was where blood vessels entered and left, and where the bronchi, main stem bronchi, entered. So it's simply an entryway. And in the hilum, we see that there are blood vessels, and we see the renal pelvis where
Don't do that ever again.
urine leaves. We're going to look at it in a large picture again, okay? So the renal pyramids end at this very tip, and that very tip has all of these tubules leading to it, and this is where water starts to leave and waste products in it. And it will be picked up by these funnel-shaped things called the minor calyx. Each pyramid will have a minor calyx. Each pyramid will have a minor calyx. We can see minor calyxes here, so they're leading to other pyramids that we don't see in this section. And when we get a bunch of minor calyxes, we get a major calyx. When we get all of the major calyxes taken together, we get the renal pelvis. The renal pelvis leads to the ureter.
Yes.
Now, the renal papilla is the very top of the pyramid, and it looks like that. It looks like in this hole, we see lots of little holes. So that is what this edge looks like. It looks like lots of big tubes leading to a funnel. Does that make sense?
Yes.
Okay.
I should have called it a common instead of calyx.
Say that again?
Now, I said they should have called it common, you know how it branches out all these tubes?
Yeah. Unfortunately, we don't get to name things in textbooks. Okay? And if you want to get your name in a textbook, name something. Okay. Now, on this model, we're seeing two different nephrons. One's a short one and one's a long one. We're going to look at those in a little bit. We see that all of Bowman's capsules are in the cortex, and all of these portions, which are called the loops of Henle, Henle, are in the medulla. We see that the nephron joins with a connecting duct to a collecting duct, and these would be collecting ducts, and ends in a papillary duct, which ends at the renal papilla. In between pyramids are renal columns, and these are how blood vessels get to this area where they delineate the cortex from the medulla. So renal columns are also in the medulla. Okay, we're going to go to the next one. Now, we see, this is labeled types of nephrons. We see that there's a short nephron and a long nephron. The short nephron has Bowman's capsule, squiggly line coming out of it called the proximal convoluted tubule. The start of the loop of Henle, and it's very, very short. So it's mostly in the cortex. They call it a cortical nephron. Now, juxtamedullary are these lower nephrons. They're much lower, but they still have squiggly line, and they still have loop of Henle, but the loop of Henle is longer. So they're the juxtamedullary nephrons. Okay?
So the only difference is one is longer? That's,
The way you tell is one is longer.
I see.
Okay? The short ones are the cortical nephrons. They make up about 85% of your nephrons. So their job is to make urine. The longer ones, 15% juxtamedullary, their job is to get most of the sodium, most of the chlorine, and most of the water back in the body. Okay, more about that when we look at an enlarged Bowman's capsule renal corpuscle. You'll also notice that there are blood vessels throughout the cortex and blood vessels throughout the medulla. Their job is to reabsorb what the kidney is giving them. Kidney's amazing. Without kidneys, you wouldn't last a day. Okay, we're going to go to the next picture. Okay, and just moving that out a little bit. Okay, we see a renal corpuscle, which consists of Bowman's capsule and the capillary network glomerulus. Now, blood goes in, blood gets filtered by glomerulus, and what is allowed out of glomerulus goes into the proximal convoluted tubule. You can see it's squiggly, that's convoluted. Proximal means proximal to Bowman's capsule. Okay. Now, at the glomerulus, the glomerulus allows into Bowman's capsule pretty much everything that's in your blood except for red blood cells, white blood cells, platelets, large, medium, and small proteins. Everything else goes into Bowman's capsule, which means you lost a lot of glucose, you lost a lot of amino acids, you lost a lot of fatty acids, you lost a lot of sodium, you lost a lot of chlorine, you lost a lot of magnesium, you lost a lot of potassium, you lost a lot of vitamins, you lost and lost and lost. The job of the proximal convoluted tubule is to reabsorb into the cortex all of your glucose, all of your amino acids, all of your fatty acids, about 65% of your sodium, about 50% of your chlorine,
This cortex is everywhere.
most of your vitamins, most of your minerals, okay, are reabsorbed back into the body. Now, this system is like this because we have to get waste out. And waste has certain properties that allow it to be dissolved in blood. But in order to do that, we have to allow all those other things to go out and then get reabsorbed back. Okay, everybody with me?
Yeah.
Yes.
Okay. Now, let's follow this around. There is, following it from the proximal convoluted tubule, it goes down, so that's the descending limb of the loop of Henle. It's going to make the loop, that would be the loop of Henle proper, and then it's going to go back up, so that's the ascending limb of the loop of Henle, which leads to the distal convoluted tubule. Now, number 5, right there, everybody see that?
Yes.
That is the connecting duct, which goes to the collecting duct. We can still reabsorb things at the distal convoluted tubule, connecting duct, and collecting duct, but only under the influence of hormones. The hormones would be ADH, antidiuretic hormone, and aldosterone. And more about aldosterone when we look at Bowman's capsule. This facilitates the reabsorption of water directly, ADH, and facilitates the reabsorption of water indirectly, that's aldosterone, which causes the distal convoluted tubule, connecting duct, and collecting duct to reabsorb sodium. Chlorine follows sodium, and water follows sodium chloride. And now we have a capillary network where we can reabsorb it into the blood. Okay, I'm going to move this down. Okay, and here we see these things labeled. Here we see these things labeled. Now, even though this was the descending limb of the loop of Henle, we now see that there is a wide part, which we call the thick descending limb of the loop of Henle, and there's a thin part here, which we call the thin descending limb of the loop of Henle. And on a cortical nephron, we get, after the loop of Henle, we get the thick ascending. Now let's take a look at the juxtamedullary nephron. We get Bowman's capsule, proximal convoluted tubule, thick descending, thin descending, loop of Henle proper, thin ascending, thick ascending, and then the distal convoluted tubule. Connecting duct, collecting duct. Now, if I go further down in this region, we're getting near the renal papilla. This would be the papillary duct. Make sense? Anybody?
Yes. Makes sense.
Yes.
Okay. So now, we're going to look at the blood vessels. We start with the renal artery. We go into segmental arteries. Then these branches become the interlobar branches between the lobes. Then into the arcuate artery. And then into the cortical radiate. In the cortex, radiating off of the arcuate artery. So that's the name that makes sense to me, because we have interlobar, and another name for cortical radiate is interlobular. And being a dyslexic, that's a dyslexic's nightmare. Okay? Is it interlobar? Is it interlobular? Did I spell this right? So cortical radiate is my preferential. Now, if there's a cortical radiate artery, there's a cortical radiate vein. If there's an arcuate artery, there's an arcuate vein. If there is an interlobar artery, there is an interlobar vein. If there is a segmental artery, there is no segmental veins. So this would be another interlobar vein. So there are no segmental veins. And then if there's a renal artery, yes, there's a renal vein. So the renal artery would be coming off of the abdominal aorta, and the renal vein would be going back to the inferior vena cava. Okay, so you got to know your blood supply in and out.
That's a lot.
Okay, now we're going to further delineate, okay, some blood vessels. Okay. We're going to further delineate some blood vessels. Okay. And coming off of the cortical radiate, going into Bowman's capsule, is the afferent arteriole. The afferent arteriole turns into glomerulus inside of Bowman's capsule, and then turns into an arteriole coming out of Bowman's capsule called the efferent arteriole. So afferent in, efferent out, just like the nervous system and the spinal cord. Now, these efferent arterioles turn into a capillary network called the peritubular capillaries for the tube's proximal and distal convoluted tubules. So reabsorption back into the body of most of your things take place in the cortex. If it's going to be reabsorbed back into the bloodstream, we need capillaries, and the capillaries are called the peritubular capillaries. Okay? Here is the afferent arteriole going in, the efferent arteriole going out, and the capillary network called glomerulus. Now, excuse me, I have to take a sip of water. By the way, today is my first day back at chiropractic practice.
Oh. Oh. Congrats.
Yeah, thank you.
Did you have a lot of people waiting today?
I saw, in 3 hours, I saw 20 patients.
Oh my God.
Oh, and that's not a whole lot. In 3 hours, I can see 50 patients.
Jesus.
Okay, so I was up at 5 this morning.
Wow.
Okay, so now you can see that this portion is uncovered and this portion is covered with what's called podocytes, and they are the visceral epithelium of Bowman's capsule. So Bowman's capsule has a parietal layer and a visceral layer, and these would also be covered with podocytes, but they removed them on this side so you could see what glomerulus looks like, and all these little holes in it make it a very leaky capillary system. Having the podocytes cover this keeps in red blood cells, white blood cells, platelets, large, medium, and small proteins. So they have, if you take your fingers and interlock them, okay, you can still see that there are gaps. No matter how tightly you lock your fingers together, if somebody was to pour water in that, it would start leaking out. But if that water contained, say, pepper, the pepper would stay in. The pepper would be your blood cells and proteins. The water would be filled with all of your nutrients, glucose, amino acids, fatty acids, vitamins, minerals, and your waste products. So the podocytes act as a filter. So they are called filtration slits where the fingers interlock. Okay, and Bowman's capsule consists of this outer layer and this inner layer. The podocytes are actually the inner layer or the visceral layer of Bowman's capsule. Okay. Now we see the afferent arteriole going in. We see it get an enlargement, and we see that the distal convoluted tubule is very, very close to the afferent arteriole. We also see blood in and urine out. So this is the beginning of the proximal convoluted tubule. And let me see if I can just do something. Okay. You can see that it is simple cuboidal epithelium with microvilli on it. Now, where did we see microvilli? In the digestive tract, right?
Yeah.
It was actually columnar epithelium with microvilli, but that was for reabsorption. Or that was for absorption, I should say, of digested material in the small intestine. Here, these microvilli are doing the same thing. They're reabsorbing. Okay? They're going to take in and then put out from urine. They're going to take in the glucose. 100% of your glucose is reabsorbed in the proximal convoluted tubule. They're going to take in your amino acids. Roughly 100% of the amino acids are reabsorbed. They're going to take in your fatty acids. 100% of your fatty acids are reabsorbed. They are going to take in 65% of your sodium, 50% of your chlorine, and probably vitamins, minerals, etc. Okay, that's only half the job. Now we're going to move down. So in this picture, what we are seeing is the afferent arteriole going into Bowman's capsule, the glomerular capillaries, the efferent arteriole coming out, and then the efferent arteriole breaks up into a capillary network that surrounds the proximal convoluted tubule, the distal convoluted tubule, and portions of Bowman's capsule. Portions of Bowman's capsule. Now, here's the arcuate artery, here's the arcuate vein. So this is a cortical nephron. This is a cortical nephron because it doesn't have very much of a loop of Henle. So this capillary network is connected somewhat into the medulla as well as the cortex. And the job of this capillary network is to reabsorb what the kidney has caused to be reabsorbed. With me?
Yes.
Yeah.
Thank you. Moving down. Okay, moving down. This is just showing you Bowman's capsule and glomerulus, except this green line should go inside of Bowman's capsule. Okay. Now, this is an excellent depiction of the flow of fluid out of Bowman's capsule out of glomerulus into Bowman's capsule, out of Bowman's capsule into these dark blue proximal convoluted tubules, then into the thick descending limb in red, the thin descending limb in purple. Now, I have learned that this is called the loop of Henle proper. So we would see purple ending about here and orange picking up about here. And now orange is thin ascending.
No, it's the truck's driving by.
Pink is thick ascending because it's going in that direction. And then we are going into the distal convoluted tubule. Okay. And then right here, that's connecting duct, and this is collecting duct in light blue. So they didn't delineate it, but I do. Okay, so this is an excellent picture. Now we have another board, okay? And I have to say that this is anatomically incorrect because we have a cortical nephron whose loop of Henle does not extend into the medulla. That's incorrect. Okay, that is an anatomically incorrect model because all loops of Henle are in the medulla. Okay? All renal corpuscles, Bowman's capsule and glomerulus, are in the cortex. All proximal, orange, and distal, purple, convoluted tubules are in the cortex. And portions of the descending and ascending loops of Henle are in the cortex, but all loops of Henle proper are in the medulla. Okay, so now we have connecting duct to collecting duct becoming the papillary duct, which is going to lead to the end of the pyramid that's called the renal papilla. Okay. Moving on to the next one. We see that there is a capillary network in the medulla and there is a capillary network in the cortex. Okay? And again, this is color-coded, so it's easy to trace out who's proximal, who's distal. But we reabsorb a lot of things into the blood in the cortex. And we reabsorb mostly sodium and chlorine, and as a result, water in the renal medulla. So the final water balance of the body is starting in the medulla, and then if the kidney itself can't bring back enough water, the distal convoluted tubule, connecting duct, and collecting duct are made permeable to water via ADH and indirectly via aldosterone, which causes the distal convoluted tubule, connecting duct, and collecting duct to be permeable to sodium. Chlorine follows sodium, and water follows sodium chloride. So the very, very final water balance is tightly controlled by those hormones. Okay? Normally, the distal convoluted tubule, connecting duct, and collecting duct would be impervious, would not permit sodium, chlorine, and water. So they are facilitated by hormones So that is called facultative reabsorption. Okay? Now,
Can you repeat that again?
say that again.
Facultative reabsorption. What was that again?
So again, the distal convoluted tubule, connecting duct, and collecting duct are normally impervious, will not permit water to leave. But under the influence of hormones, ADH, antidiuretic hormone, directly water is released into the parenchyma and then into the capillary networks. Okay. And under the influence of aldosterone, aldosterone causes the reabsorption of sodium, chlorine follows sodium, and water follows sodium and chloride. So since they are normally not going to let things out of the tubular system, but they are facilitated. Facilitated means allowed to have water channels open, ADH directly, and sodium and chlorine channels open up, and water will follow that. So that's called facultative reabsorption. It's facilitated by hormones. Okay, so now we're looking a little more at the blood vessels of the cortex and the medulla. And again, the medulla is here, the cortex is here, and that's delineated by the arcuate artery and the arcuate vein. Into the cortical radiate, into an afferent arteriole, into glomerulus, and then back out by the efferent arteriole. The efferent arteriole becomes the peritubular capillaries up here and the capillary bed of the medulla. And then we have blood vessels that go down and back, that I should go like this, down and back, okay, which are the rectifying vessels, vasorecta, the rectifying vessels that are helping reabsorb that last little bit of sodium, last little bit of chloride, and last little bit of water. And if that's not enough, we can facilitate it up here via hormones. Okay. Here we have an enlargement of Bowman's capsule, okay, the parietal portion. Bowman's capsule, the visceral portion, that would be the podocytes. And again, this is uncovered just to show you the difference. Okay, in real life, this would also be covered in podocytes.
So the podocytes, that's the covering? It's not called...
Yes, the podocytes are the covering of glomerulus. And they are, the podocytes are the visceral portion of Bowman's capsule.
So they're outside that.
They're inside. Here's Bowman's capsule.
Got it.
Okay, but that's the parietal portion. Inside of that are the podocytes. That's the visceral portion.
Got it.
Now, this is the efferent, this is the afferent arteriole. Notice that the afferent arteriole has a larger diameter than the efferent arteriole. That means there is going to always be an outward pressure forcing fluid out of glomerulus and forcing fluid through the podocytes. Here we have, okay, the
So you're saying the afferent is thicker
is larger in diameter.
in diameter? Okay.
Okay, so that causes a buildup of pressure, which forces fluid out. This is the distal convoluted tubule, and see how tightly packed this portion of cells are compared to this portion of cells. That is called the macula densa cells, densely packed cells. And the distal convoluted tubule overlaps the afferent arteriole, and these cells are called the JG cells. In there, the macula densa will tell the JG cells if too much sodium is leaving, too much chlorine and too much water. The JG cells will tell these other cells, which are called mesenchymal cells, to constrict, causing the afferent arteriole's diameter to be reduced. Therefore, the pressure that is being created in here is lessened, so less fluid will go out. Also, and let me just do one thing here. Also, if too much sodium, too much chlorine, and too much water is leaving, then your blood volume and your blood pressure are going down. Make sense?
Yes.
So the macula densa cells again tell the JG cells, and the JG cells will release renin. Now, you remember from your talk in the endocrine system, renin is an enzyme that encounters angiotensinogen, turns it into angiotensin 1. Angiotensin 1 goes to the lung, where ACE turns it into angiotensin 2. Angiotensin 2 is a potent vasoconstrictor, so your blood pressure rises. But we still have to go and get more fluid. So angiotensin 2 goes to the brain and tells the brain to cause the release of ADH, and causes the brain to tell the pituitary gland to release adrenocortical stimulating hormone, causing the adrenal cortex, okay, to release aldosterone. And aldosterone is going to cause the reabsorption of sodium, the reabsorption of chlorine, the reabsorption of water, as well as ADH is going to cause the reabsorption of water. So now we've restored our blood pressure and our blood volume. Isn't the kidney amazing?
Does a lot.
Okay. I'm priming you for lecture. I'm not going to ask any physiology. Okay. In addition, these JG cells release erythropoietin. Okay, and erythropoietin goes to your bone marrow and causes the formation of red blood cells. So who is in a better position to judge how much blood we actually have? The kidney, where all of your blood is filtered, I think it's something like every 10 minutes by your two kidneys. Okay, so now, distal convoluted tubule, they're going to call this the thin ascending, call this the thick ascending, okay? This is the proximal convoluted tubule. They're going to call this the thick ascending and the thick descending, okay? I simplify matters. If it's blue, it's proximal convoluted tubule. If it's pink, okay, if it's blue, it's distal convoluted tubule. If it's pink, it's proximal convoluted tubule, and if it's yellow, it's collecting duct. Okay, so here they distal convoluted tubule, proximal convoluted tubule, distal convoluted tubule. Okay, and important, macula densa, and JG stands for juxtaglomerular cells. Okay, so this yellow is mislabeled. It's not distal convoluted tubule. It is either the connecting duct or the collecting duct. Got it?
Yes.
Okay, so make note of that. Make note of that. Now we're going to look at the bladder. The bladder is an organ that can expand or contract.
That's for you.
The stomach is an organ that can expand if you eat a lot and contract when it's passed on, or if you're hungry, like I am at the moment. So the stomach has these ridges called rugae. The bladder has these ridges called rugae. Okay. The bladder is lined with transitional epithelium. And if you remember your histology, transitional epithelium transitions from a cuboidal to a squamous as the bladder expands and it stretches these cells. The bladder is a muscular organ. All of this is smooth muscle, and it is destrusor muscle. The destrusor muscle surrounds the beginning of the urethra, and it is the internal urethral sphincter. It is under autonomic control and will reflexively relax when we relax the external. If there's an internal urethral sphincter, there's an external urethral sphincter. Okay? Now, this is a male because this is a prostate gland. And so the urethra, okay, has three different names for three different places. In the region of the prostate, it's the prostatic urethra. Okay? This is a picture of the bladder from the posterior. And here's our prostate gland. Part of the male sexual reproductive system is the ductus deferens or the vas deferens, either one, coming from the scrotum, coming from the testes, carrying sperm. Seminal vessels add liquid to the sperm, so they have to join with the male urethra. They're going to do that in the prostate gland. So here, this is a female because this is the fallopian tube and that's an ovary. This is a female because this is the uterus overlying the bladder. So when mom is pregnant and the fetus is growing, this is enlarging and pressing on the bladder. That's why mom has to go to the bathroom quite often. Okay, so here we can see a testis. We can see the vas deferens going to the posterior aspect of the bladder and being joined with the seminal vesicle. I will ask that in reproductive, not in urinary. But now, urinary-wise. Here is the bladder. Here is the internal urethral orifice. Here is the internal urethral sphincter. Here is the prostate gland. This is the ejaculatory duct where the ductus deferens seminal vesicle joins the prostatic urethra. This is the body wall. So in here, it's called the membranous urethra. And then it enters the penis, so it's called the penile urethra. And here is the external orifice. This body wall is the external urethral sphincter. That's why you kind of tighten your buttocks when you have to go and there's no room in the bathroom. Okay, you're squeezing down on that to make sure this one doesn't open up, because if this one opens up, you're going to dribble. Okay, so these particular pictures, okay, I will do in reproductive, which is next week. So notice I'm moving rather rapidly. These are things that I don't use, at least for urinary. So, to reiterate, okay, I like this model. I like this model. I like these models on the green board and how they're delineated with who's who. All of this I like. All of this I like. All of this I like. I like this. I like this. I like this. I like this. I like this, with the notion that, or the observation that, all loops of Henle are in the medulla. Okay, I like this. 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 Okay, and this I would use in reproductive. And these models I will use in reproductive. All right?
So
Okay.
when there
Okay.
are three names of the urethra, that's only in males?
Say that again?
The three different names of like what the urethra could be called, that's only in males?
That applies to now,
Okay.
and it applies to reproductive,
Okay.
because the urethra is a shared organ of the reproductive and the urinary system, so it's apropos to both. Okay?
But I meant like the three names are just in males, correct?
Just in males.
Okay.
Females don't have a prostate.
Okay.
Okay? Okay. So
Oh, there's stuff that comes out.
everybody can leave. We're done with the lesson for today. I'm glad that some of the people from yesterday showed up. If you did not already leave me a chat to give me your grade, we can do that now.
Thank you.
Okay.
Have a good weekend.
Thank you, Professor.
You're welcome.
Thank you,
you.
Professor. Have a great weekend.
Okay.
You too.
Have a good weekend. See you next week. Oh, I'll talk to you
Okay.
next week.
I need my professor.
I sent you a chat, Professor, for my grade. This is
Right.
Stevania
What's your last name?
Williams.
Oh, yes, yes.
I sent you a message too, Professor.
Okay. Steviana?
Yes.
Okay.
Thank you.
You're welcome. And Anita,
Yeah.
last name?
Ramroop.
Hmm?
Ramroop.
Oh, yes. You're welcome.
Okay, have a good weekend, Professor.
Okay, you too.
Bye now.
Bye-bye.
I wrote you, Professor.
Me too.
Okay, hold on. I got to find you.
Clothing, income fees. Crawford had, in fact, prepared some place that he could take Christie back to.
Hello? I eat some.
Quiéreme así, ¿no?
Hey, children, I'm looking up yours.
Capture, check, and hopefully get Christie Ray safely back to her family. So Larry made any sense of a resolution.
Setting off on foot, the officers search for powers.
Así no, Jeremy.
Hold on.
As the evening approaches, there is a clear shot for their target.
Ah, here we go.
I think on it. Get up. Look, I think.
You're always concerned about when you're tracking someone and you're trying to capture someone and they have a hostage, is the safety of the hostage.
Forced to suspend the search for the time being, FBI agents employ another strategy. They post agents at locations
Goodbye, Professor. Thank you.
You're welcome.
Get up.
It may return to the residence, so we need to have some law enforcement people ready.
Anybody else?
Me.
Who's
Brianna.
me?
Brianna Debrell. Thank you.
You're welcome.
Have a good weekend.
You do the same. Study well.
All of a sudden, we heard
Hi, Professor.
Bye-bye.
she's at the house.
Where's that problem with it?
They see Crawford approaching the house, and he is armed with an over and under double-barrel shot. They were prepared for a violent confrontation.
I wish I could say, Robert, don't go to work because you're going to die.
You three are here, still here for a reason.
That's where he took his last breath.
Sunday at 9 on
Restaurant Impossible returns with the most life-changing season ever.
It raised $118,000.
Season premiere, Restaurant Impossible, Thursday, May 15th at 9 on Food Network.
Usually when you're hearing from me in the channel, we're talking about affordable car insurance, and we're having fun. But right now, times are tough. So we hope your family is staying safe at home, because even though we're here to protect
Ariana, you're here for a reason.
soon enough we'll be back on the road. Shakalicious. And back to our usual fun. To be or not to be. For 55 years, the Journal has stood by our customer with vague loss of insurance or needed payment flexibility. So if you need help, call always, but most important, stay safe.
Water brings nature to life. Together, they bring you life with the power of essential oils. Introducing the Moen Aromatherapy Shower with India. Water designs our life. Who designs for water?
How about you?
No. No way.
Come on. No. No. No.
Yeah.
Only Discover has no annual fee on any card.
Wake up to great tasting flavor. Belvita breakfast biscuits. Flavors like delicious blueberry or decadent chocolate gently baked in a tasty biscuit. Belvita breakfast biscuits. It's time to taste the day.
They are compelled to step forward to the front lines and into the unknown for all of us.
How do we make a scented oil plug?
You guys are still logged on. I'm going to log you off.
Airwick scented oils are infused with essential oils that are 100% natural to fill every corner with the fragrance of nature. Airwick.
Well, I'm used to say go and play, but inside the place we don't play the game. Not just the little ones, grown-ups too. Checking the world with a different view. Let's stay connected, one with the flow. Let's stay playful. Or you.
What makes you you? Yourselves. Trillions of them. That's why Centrum contains 24 key nutrients to feed your cells, supporting your energy so you can take care of what matters most. Centrum. Feed your cells, fuel your life. This is Corona Hard Seltzer. The only hard seltzer made with pure beach flowers. With the taste of blue skies in every can. And a refreshing splash of fruit flavors. 0 grams carbs, 0 grams sugars, 90 calories. There's a lot to like about that. It's another way to find your beach.
They are the heroes, helping on the front lines. Here's one small way you can help them in return. Complete your 2020 census today. Census data helps communities plan funding for hospitals and emergency services. Respond now at 2020census.gov.
What makes you you? Yourselves. Trillions of them. That's why Centrum contains 24 key nutrients to feed your cells, supporting your energy so you can take care of what matters most. Centrum. Feed your cells, fuel your life. Every toy built is tested to make yard work the best work. Get the reliable Pony 42, starting at $13.49.
Being nosy is a good thing. Like if you suspect a natural gas leak in your home or your neighborhood, it can produce a funny smell, similar to rotten eggs, a hissing sound, or a hazy white cloud. If you notice any of these signs, don't touch switches or use the phone. Get outside immediately. Then call 911 or your natural gas provider. Being nosy can keep you safe. From the member companies of the Northeast Gas Association.
We're in the Outback. This is a new team. Tyler is the short version of Parker. I will mine in hell if the sounds good.
The global pandemic has affected us all and left millions without food, protection, or education. Let's show the world that even though we may be apart, we can all rise to help those most in need right now. Donate today at discoveryrise.org.
Wanted suspect Chuck Crawford has just shown up at the house of his ex-father-in-law. where FBI agents are already posted inside.
Don't know what Crawford's reaction was going to be. He was armed with a shotgun. Obviously, he was a threat.
Back up.
There was an adrenaline rush and excitement that you got Crawford in custody. But he doesn't have Christie. We don't have Christie. Where's Christie?
Chuck Crawford is immediately taken to the FBI's makeshift command post at the local elementary school for questioning.
Chuck, why don't you tell us who Christy is? I was on hunting all day. I don't know nothing about this Christy person.
Initially, he denied any knowledge of that. He didn't know anything about Christy Ray. And after about 20 minutes of questioning, Crawford broke down.
Chuck, is Christy alive? Where's Christy? Yeah, I ain't gonna find her without me.
That same night, Chuck Crawford leads investigators deep into the Mississippi woods.
She's right there. Sir.
He had concealed her body beneath some leaves and some brush. Christy was handcuffed behind her back. She had a gag around her mouth. Also, her clothing had been pulled down below her waist. The autopsy determined that Christy had been raped. A single knife wound that penetrated the heart, the lung, and she lived for about 1 to 2 minutes before dying. 1 to 2 minutes may not seem a lot of time, but you just have to think about what thoughts were going through her head. Obviously, 1 to 2 minutes is a very long time considering the ordeal that she went through.
2 days later, Agent Summerlin meets with Crawford to try to get a detailed confession.
Hi, Chuck. So how'd you know Christy? I didn't know her. Just saw her around town a few times.
His version of events was that Friday morning, his mother dropped him off in Cleveland, Mississippi. He was concerned about his upcoming trial. When he had things that were worrying him, he said he would go to hunt and hike. But the next thing he knows is he's standing inside of the Ray residence. He was in a panic. He didn't know what to do. And he decided to take her car, put Christy in the car with him, and flee while he tried to figure out what to do. And when we asked him, what about the ransom note that Mary found at the residence, he denied any knowledge of that. It seemed like at very critical points of the events, he had convenient blackouts.
The following day, an officer shows up on the land where Crawford is hiding out with Christy Ray. And that's when he claims the innocent encounter took a violent turn.
He claims that they were going to walk through the woods back to Christy's car where they had left it, and he was going to turn himself in. As they're walking back to the car, all of a sudden he has a blackout.
obviously must have killed Christie, but claimed he couldn't remember what happened. I just don't believe it. I don't believe it. It's just too convenient.
Charles Crawford is found guilty of capital murder and rape. He is sentenced to death on April 23rd, 1994. Nearly 26 years later, he still sits on death row.
It's terrible to think somebody's waiting on somebody else to die, but that's what I'm waiting on. I hate to see him outlive me, and Mary does too. But the way it's going, he probably will. That'd be a shame. We had 20 good years with Christy. And that's what we look at. She always come a bouncing in. She's always had that big smile. She was one of a kind.
A lot of people go to the cemetery and visit their loved ones. I go to her bedroom. That's where I go, and I talk to her. It's still heart-wrenching. She was our only child, and we thought, well, this is all we need. We're going to give her everything we couldn't have and make her life as good as we could. Christy Ray was my best friend. I miss her. Every day I miss her.
Conyers was one of the fastest growing metropolitan counties in the Atlanta metro area at the time. It was pretty much known for its bedroom communities, subdivisions for people that would commute, but still some rural areas in the county.
Kathy Whitehead was a young lady. She lived in an apartment complex in downtown Conyers.
She was a young mother. She had me at a young age, and she was making ends meet the best way she could. Loved life a lot, and she was always pretty happy and outgoing person.
Kathy was dating and engaged to a man by the name of John, who was a police officer in Porterdale, Georgia.
Darling, you spoiled me.
Not nearly enough.
Oh, stop it.
John and Kathy initially met when Kathy had reported a vehicle stolen. John was the responding police officer. It was like love at first sight.
She was really into John, Most of the time when they were together, I wasn't always around. She was definitely happy with John.
Kathy, I have some news.
Well, what is it?
Hazel, sign the papers. This divorce is going to be finalized before too long.
You're kidding me. Oh, honey, that's great news.
John had been married for, I think, something like 23, 24 years. And they had some children. And John decided that he was going to divorce her.
Well, sit down. I made a great dinner for you.
Yeah, what's for dinner?
Chicken, carrot celery,
Can I help?
no, some jelly, and bread. But only 2
I don't think Kathy really knew that she was being stalked.
The following day, Kathy arrives for work at her usual time.
Kathy was working as a cook in one of the local restaurants.
Darn James again? You gotta be kidding me.
Kathy was not happy about this particular cook's poor performance.
Kathy and this coworker had some altercation at the restaurant that they worked at.
James, you are 20 minutes late and none of the prep work was done last night again.
Come on, Kathy, what's the big deal? We ain't even got no customers yet. And you know we ain't busy on Sunday mornings.
Have you been drinking?
Not since last night. Didn't have time to go home and get cleaned up, so I had to come here straight from the party. Girl, you know how it is.
You know what? I'm gonna talk to the owners. You best start looking for another job.
What? The hell you are? I need this gig.
You don't deserve this job.
You keep me gone, Kathy, I swear.
I regret it. Kathy provided to the owners of the restaurant information that got that cook fired.
That December, Kathy is at home when she receives an unexpected letter.
No, it ended.
It's over? You shut it off?
No, I don't.
When did it end?